Hi, a few of you have requested I go through the topics individually that are likely to come up on Monday's Edexcel exam, so that's what I'm going to do now. If you haven't checked out my predicted paper, then please check it out by clicking the bottom left predicted paper, and that's a predicted paper based on questions that aren't Edexcel questions, but of the same style of topics that are likely to come up. All the big hitters from today's video are on that paper. Okay, before I start, I'll show this before every video I do. It's all of the previous exams in the last few years and what grades, what marks you needed for each grade. So for example, a C grade on the higher, you need somewhere between 22 and 32. I'd say if you get 30%, then that's pretty safe C. A star I've been asked a lot about, so you can see that you need to get about 85 to get a safe A star. I think it's going to be around 81 maybe this year percent that you need for an A star, and then foundation is red on the side, so for a C grade on foundation you need in the mid 70s. I'm not going to go through it. You can see all of the previous exams there, so you can have a look at that if you want to pause the video. Anyway, so let's get started. The absolute essential topics to revise for Monday are these two: trial improvement and sampling. Now, just to explain what these columns are, these 71% here are just the chance of them coming up on either paper, the non-calculator or the calculator, and these percentages here are specifically the calculator paper. So you can see here, every time trial improvement has come up and every time stratified sampling has come up, it's always been on the calculator paper. Combined, they're worth 6 marks. Now, trial improvement is a C grade topic, stratified sampling is an A grade topic. If you're worried about doing an A grade topic, it's exactly the same as relative frequency, which is a C grade topic. So stratified sampling isn't that difficult for any students to answer. So I definitely recommend you look at these topics even if you're not looking for an A. So there's 71% chance, which means they've come up on almost all of the papers that have come before. The next slide I'm going to go through is 57% chance topics. Trigonometry is a staple for calculator paper. Now, trigonometry that is SOHCAHTOA will come up. Sometimes it comes up in an obscure question where a lot of students who maybe learn the basics of trigonometry but don't understand the bigger concepts, they don't understand that it's a trigonometry question. There's sometimes two right angle triangles put together, which throws a lot of people again who are slightly weak at trigonometry, but it will be on there. So if you've got any right angle triangle or you can make a right angle triangle, then have a look at trigonometry as a tool to be able to answer it. Pythagoras did come up on the last paper, but the likelihood of it coming up again is quite high, because on the last paper it wasn't obvious you needed to use Pythagoras, and they might do a standalone question on Pythagoras on the next paper. But if you had to choose between trigonometry and Pythagoras to revise tonight for Monday's exam, I would pick trigonometry. Inequalities also came up in the last paper, but it was a graphical inequalities question. I would say being 86% chance of of having to solve an inequality means that it's likely that it will come up, and writing the integers from where it's shown on a number line is also one. I would revise those. If you know how to solve equations, solving inequalities, it's not going to take you that much more time to understand. Instead of an equal sign, you just put an inequality sign. There's a few more rules you need to learn, but that's not a difficult topic to revise. And this one here, writing integers from inequalities, is a really quick topic to revise. You just need to know if it's filled in, it equals that number. If it's not filled in, it doesn't equal that number. And the last thing you need to know is integer just means whole numbers. Transformations, describing translations have come up quite a lot. Now, translations weren't on the last paper, although it did have 2 transformation questions. Again, it makes it a little bit less likely to come up, but given the fact it's come up 57% of the time on the calculator paper, it will be worth revising. Remember, for translations, the top one is how far right and the bottom one is how far up, and if you do it with jumps, it's nice and easy. This one, using a calculator, so just writing the full calculator display, is one that is almost certainly to come up. They like using it. It's a nice introduction to the paper. It'll be one of the first few questions. It gives them an opportunity to introduce rounding as a standalone question, because the question 1 will be write the full calculator display, and question 2 will be rounded to one significant figure. Remember, with significant figures, if you get an answer of 39.6 and it asks you to round to one significant figure, it's going to be 40 to one significant figure. A lot of people would write 39 or whatever. Actually, it's a bad example. It should be 39.3. A lot of people would write 39. One significant figure means there will be one number that's not a 0 in your answer. So just remember that one. As you can see with the marks here, there's 6, it's been a long day, 8, 10, 12, 14 marks in total. So if all these questions come up, it's already influencing your grade. Now on to the good topics to revise. They're just under half a chance of coming up, but still quite significant. Bounds is a quite good A/A star grade topic for them to put in. It will be an obscure question that says what's the maximum possible or what's the minimum possible, and it only gives you 2 numbers. The hint normally is that they've told you what they've rounded the numbers to. They don't always say that though, so you're just going to have to look at the question and think, oh hang on, for 5 marks this seems a bit easy, that you just have to divide these 2 things together. Remember, if you've got a division, if you've got a fraction, so if you have to divide something by something else, the number at the bottom of the fraction, the number you're dividing by, the bigger it is, the smaller your answer will be, and similarly the smaller it is, the bigger the answer will be. So you're not, if it asks you for the maximum, you're not just picking the upper on both. If you're dividing, you go pick the upper one, the biggest for the top of the fraction, and the smallest for the bottom of the fraction. Circle theorems, that's one of my favourites, apart from try and improvement stratified sampling. Circle theorems is one of my favourites to come up. You've just got to learn all the circle theorems. A little bit of a hint, you do need to learn why for some of them. If you have a tangent and a radius coming from it, you need to know that that's a right angle. But if you have a tangent without a radius coming from it, if you have a triangle coming from it, you need to know alternate segment theorem, which says that the angle between the triangle and the tangent on one side is equal to the angle inside the triangle on the other side. Any revision guide or textbook, or if you just type it in online, you can see a diagram that explains that. But if you've got a tangent hitting a circle, your choice is one of those 2. Cyclic quadrilaterals they like using, which is where you've got a quadrilateral 4-sided shape inside a circle with all points touching the circle. The opposite corners will add up to 180. Angles from a diameter always 90. Angles from the same arc always the same. And you can look at all the circle theorems, but the reasons are quite important to revise for that. If you are not an A grade student or not a B grade student and you're looking for a C grade and you want to try and have a go at circle theorems, generally I say if 2 angles look the same, then they're probably equal, and that normally is enough to get a few marks maybe for that. The last thing on circle theorems I want to just highlight is there's a lot of times where you have triangles that you've got one angle and you can't figure out how to work out the other angle. One important thing to remember is if you have a triangle that's made up of 2 of the lengths being radii, it means it's an isosceles triangle. Okay, so look out for that in the exam on Monday. Mean from a group frequency table, you just need to learn the steps. You first of all work out the midpoints, then you work out the fx, which is the frequency times the midpoints. You add up the frequency column and the fx column, and then you swap them around and put a divide sign in there. And that's a C grade topic, so everyone needs to absolutely make sure they understand that. You could also be asked for the modal class. The modal class is just the group with the highest frequency, so it could be 0 to 10 or 10 to 20. Quadratic formula is again likely to come up. You're asked to factorise and solve quadratic in paper 1, so in paper 2 they might ask you to use the quadratic formula. Dead hint for using the quadratic formula is the fact that, well, first of all, they've already asked you to factorise and solve on paper 1 for that famous question with the sweets. Secondly, it will say round your answer to 2 decimal places, or sorry, round your answers to 2 decimal places, or something like that, where you're not going to get it to 2 decimal places necessarily if it is a factorizing question. The exchange rates are, again, a likely topic to come up. You just need to know how to use exchange rates one way and then how to use them the other way. And if you look at any past paper question, you'll see what I mean by that. So sometimes you're timesing it by the exchange rate, and the other times you're dividing it by the number in the exchange rate. If you have a look at my other video, you can see a good question on exchange rates. Compound interest in some form is likely to come up. You need to know how to make a multiplier. So if something goes up by 15%, you need to know that you do 100, which you always start off with, plus the 15% to make 115. And to make it into a multiplier, you divide by 100, so 1.15. You then do to the power of the amount of years that you get the 15%. So if it's a bank account, 15% for 5 years, you do it to the power of 5. Standard form is, my instincts tell me that they are not going to put a standard form question on a calculator paper because you can just use the calculator to work it out. However, they have done a standard form on the calculator paper quite a few times, as you can see. I would assume the only difficulty you're going to have on a standard form question is writing the number in standard form. The way you do that is you need to have a number between 1 and 10 times 10 to the power of another number. And if you write the number down, the full number, so say 180,000, you work out where the decimal point is now, and for any integer it's just at the end of the number, and you count the amount of jumps you have to make to get the decimal point to make that number a number between 1 and 10. So if it's 180,000, the decimal point would be between the 1 and the 8 to make 1.8, and it would be times 10 to the amount of jumps that you had to make. If you're looking for anything higher than a C grade, I would revise how to make standard form and how to undo standard form for that. Quadratic graphs are, I think it's one of the ones that they'll ask. It'll either be draw a linear graph or draw a quadratic graph. I'd imagine if it's on the calculator paper, it's a heck of a lot more likely that it's a quadratic graph because they want to test your skills of putting numbers into a calculator. The biggest points to make with quadratic tables and drawing quadratic graphs is, first of all, if you put in a negative number into your calculator, just put brackets around it. The reason for that is a lot of people see x squared and they want to put in -3. They type in -3 squared. The problem with that is the calculator does the 3 squared first to make 9 and then puts the minus in front of it, so it becomes -9. But you should know that -3 squared, any negative times a negative is a positive. If you put brackets around the -3 and then put the squared, the calculator will do all that work for you and will make it a +9. The other point with drawing quadratic graph is that you need to plot the points on the graph, and the graph probably is going to be there for you. Sometimes they're not. And then when you join them up, you can't use a ruler, you have to do it freehand. I find it much easier to turn the paper on its side and draw it that way because it's a bit easier to do the motion of the curve when I do that. Also, the last point on that is if you have 2 points at the bottom of the U-shape or at the top of the U-shape, depending on which way around the U-shape is, you have to show that your curve is going beneath those 2 points. So if I draw one here just with my mouse, so as you go down you might have 2 points here at the bottom. You've got to show that it goes below those 2 points. Again, if you're not sure what I'm talking about, have a look at drawing quadratic graphs in your revision guide or textbook or online. Expanding quadratic, you did have to expand surds on paper 1, but you didn't have to expand a quadratic. The only thing I want to talk about on that is if you have brackets x plus 2 close brackets squared, don't forget that you can't just square both of the things inside the brackets. You've got to write down 2 sets of that bracket. So it'd be x plus 2 brackets x plus 2. And then you solve it that way. Loads of people use different techniques. You can use grids or foil or double smiles and rainbows or smiley face. There's a whole load of things, and your teacher might have come up with their own way of you remembering that. Finding the nth term is pretty simple, but again, it's likely to come up. First thing to work out is what the sequence goes up in, assuming it's a linear sequence, which they normally ask. So if it goes up in 4s, you write 4n, and then you work out how to get from that 4 to the first term. And so if the first term is 2, then you do, 4 take away 2 gives us that 2, so it'd be 4n minus 2. Little glance in any revision guide, you'll see what I mean. And drawing frequency polygon, most important thing for frequency polygons is you plot things at the midpoints. And so frequency polygon is just plotting little crosses at the midpoints and then join them up with straight lines. You do not join them up to make a polygon. So you don't join the first and last up together to make a complete shape. You just leave them as they are, and sometimes you do lose marks if you do that. Okay, on to the lesser good but still good topics to revise, and there's getting quite a few of them now. So I'm going to go through them a little bit quicker. You can see as some of these are very high likelihood of coming up generally, but slightly lower likelihood of coming up on the calculator exam. That means that maybe, simplifying algebraic fractions, there's no reason that wouldn't be on the calculator paper. So some of these could come up, and so they're definitely worth revising. Simultaneous equations, which I haven't mentioned at all, because the statistics say they're not as likely to come up as the other topics. I would still definitely revise both types of simultaneous equations. There are quadratic simultaneous equations, and there's the standard simultaneous equations, the linear ones, where you try and get the coefficient of x or y the same, and then you either add or subtract going downwards. The quadratic ones you do by substitution, so you get y equal to something and then get the second equation, substitute in the whatever y equals into that. If you want to have a look at that, that's in any revision guide or textbook or online. Sometimes they link Pythagoras and trigonometry, like with the question I was talking about before, with two right angled triangles touching each other. One of them you need Pythagoras, one of them you need trigonometry to work out. Circle areas, normally they've got a problem revolving areas of circles, so remember pi r squared for that. They have questions linking number and shape, space and measure, so they've got pound amounts or whatever, and into a shape, and you've got to work out tiles or whatever. There was a question very similar to that on the first paper, so it's less likely to come up. You had to compare stuff. They like comparing banks or comparing water boards or comparing electricity supplies, so that might still come up. Finding percentages in a more functional question, so it's hard to predict what type of question that will be, but make sure your percentages are up to scratch. Length scale factor, that is when you have an enlarged triangle and you're looking for looking to find the length, find a missing length on the bigger one, and then finding a length on the smaller one. So you need to find the scale factor, know that you times it by the scale factor to go one way, and you divide it by the scale factor to go the other way. Recipes will be maybe one of the first few questions. So you've got to, just like scale factor, you've got to work out, so if the first one's a recipe for 20 people and you want it to be a recipe for 30 people, you do 30 divided by 20, which is 1.5, and you'll times all the ingredients by 1.5. Histograms I think are very likely to come up, just like the speed, distance, time triangle where distance is at the top. With histograms it's frequency at the top and frequency density and class width at the bottom. You'll probably have a frequency table, and the first column to add is the class width column. So if it's 0 to 10, the class width will be 10. If the next one's 10 to 15, the class width will be 5, because it's the width of the class, the width of the group. And then you do the frequency, which is given to you, divided by the class width. Be careful, because the class widths probably will be different. So if you work out the first one's 10, don't divide all of the frequencies by 10. You've got to work out what the class widths of each individual one are, and then just plot that onto a graph. Now the graph is a histogram is very much like a bar chart, but there's no gaps, and the bottom scale is continuous, so it goes 0, 1, 2, 3, 4, or 0, 10, 20, 30, 40. So it's basically a bar chart if you've not used histograms before. Simplify algebraic fractions. With that, you're looking at factorising the top and bottom. The top one sometimes is a difference of two squares, so it would be x squared minus 9. Make sure you know that you can make two brackets out of that, which is x plus 3 and x minus 3, or it might be x squared minus 64, which would be x plus 8, x minus 8. One of the brackets at the top and bottom will be the same, so you can always cancel. If you've got algebraic fraction question, you'll always be able to cancel one of the brackets top and bottom. So it's a good way of checking to see if you've got it right with the factorisation. And also the one at the top, the numerator, is normally the easier one to factorise, so it might give you a hint of what the factorising or what one of the answers is to the bottom one. We've already talked about histograms. Solving linear brackets, I call it smiles and rainbows. You just need to times the number on the outside by both of the numbers on the inside of a bracket. Reverse percentages, you work out the multiplier, but then you divide it by the final amount to get the original amount. Trigonometry we've already talked about. Trigonometric area, you just need to look at, or know that you need to look at the formula in the front page of the exam, on the formula booklet, or the formula page. It has the full formula there, and it tells you what big A and little a are. Big A is an angle, and little a is the one opposite the angle, the length opposite the angle, if I can speak. Proof, there will be, proof is difficult to predict because they could ask to prove on a whole load of things. This one came up a few times, which is prove the quadratic bracketed equation is a multiple of A. So prove that this chunk of algebra will give us a number in the 8 times table, for instance. Percentage increase and decrease. Percentage increase is change over the original times 100. So work out how much so it will say something like the TV's gone from £45 to £80, or maybe the other way. Work out the percentage increase or decrease. So you work out how much it's changed. So take away the bigger one from the smaller one, put it over the original, what it started at, and then times by 100. Solving with linear fraction. So if you've got x plus 3 over 5 equals 20, just remember that the number at the bottom of the fraction times that by both sides first, and that will get rid of the fraction. You've got to do that first. You've got to get rid of either fractions or brackets first. Comparing box plots, there are two things you need to compare. The first one is the medians. You say A has a bigger median and state the values. Say A has a bigger median at 55 and B only has 32. The second thing you need to compare with box plots is the range, or the interquartile range. The range is the total width of the box plot, so it's the highest take away the lowest. The interquartile range is the upper quartile take away the lower quartile, so it's the width of the box, so the middle bit. Range is probably the easiest to compare, and you'll get the marks even if you do the range. You don't need to do the interquartile range. But make sure it's consistent. So if you do the range of A, make sure you do the range of B, and you just say that B has a bigger range. The perfect answers for that is, if you're comparing the medians, you say on average A is bigger. If you're comparing interquartile range or range, you say the spread of the data for B is wider or bigger. Expanding multiple linear, that's like 5 brackets 2x plus 3, close brackets minus 2 brackets 3x minus 4 or something. The important thing to remember when you're expanding multiple linear is for the second bracket, if you have like a minus 2 before it, then that number is minus 2, and you're timesing both the numbers in the second bracket by minus 2. A lot of people make that mistake. We've already talked about drawing quadratic. Circumference, you just need to know that the formula is pi d, pi times the diameter. If you've got a radius, you just need to remember to double it first. Sampling, there might be, why is this not a good sample? Typical answers are that they're only asking one type of person. So if you're asking people about their political views and you're stood outside a woman's clothes shop, then chances are you're only asking females. And also that the sample's not big enough, so they're not asking enough people, that they've only asked 5 people, and that's not a good enough sample. for indices, simplifying brackets, so you just need to remember that anything on the outside of a bracket you times by any power on the inside of the bracket. And with numbers, if you have any numbers on the inside of a bracket, then you just do those numbers to the power of what's on the outside of the bracket. It says show A is in a sequence, so it goes with the sequence question from earlier. It might say show that 256 is in the sequence, or is 256 in this sequence that we've given you. Easiest way of doing that is just carry on the sequence, just keep adding 8 or whatever the sequence is. There are other ways of doing it. You can get the nth term equal to 256 and see and solve it, and if n equals a full number, an integer, then it is in the sequence. If it doesn't, then it's not. If you're not sure about that, then just carry on the sequence. Just make sure that you've got enough time to do that, because some of the sequences do go on for a while. Modal class we've already talked about, and rounding to one significant figure we've already talked about. Okay, these are the main topics to revise. I massively recommend you revise these topics, because these are the ones that are almost certain to come up in big amounts. So maybe 80%, 90% of the topics I've just shown you will come up. These are less likely to come up, but still worth just having a look through. I've not included the other data for these because there wasn't enough space on the screen. But if you have a read through them, sine rule, cosine rule are quite important. Because they're linked with everything else, the area of a triangle, they'll only ask a question on either sine rule, cosine rule, area of a triangle using those formulas. They don't often ask ones that link cosine and sine rule together, but there's different combinations of them. So they're definitely worth, out of this list, they're definitely worth looking at if you're looking for an A or an A star. Trapeziums, just make sure you know the formula for it. It is given to you on the exam formula sheet. There's a few other ones. Linear graphs I haven't talked about at all. They're worth looking at. I've avoided probability because of the fact that there was a lot of probability on the first paper, so it's unlikely to come up again. But stuff like knowing y equals mx plus c, so m being the gradient and c being the y-intercept, is a good thing to know for the exam. Drawing side elevations, plans, front elevations would be a good thing to revise. And knowing what reciprocals are. And also ratios really didn't come up in any of the previous slides, so ratios might be a nice topic to look at. They occasionally ask about 3D coordinates. Just remember that the last coordinate is the 3D-ness, so you have the x coordinate, then the y coordinate as usual, and then you have how far out the page it is for the z coordinate. And finding areas of parts of a circle, you just need to work out the angle of the sector that you've got and put it over 360 and times it by the total area of the circle. I don't see any more here that I think will come up. So it's basically just linear graphs, cosine rule and sine rule are the big ones that you will need to look at before the exam. Okay, so now we're on to the ones that have come up on the non-calculator paper before but haven't come up on the calculator, so let's have a look. So it's not appeared on the calculator paper before. Things like knowing that the power of 0 will always give you 1 is a good thing. You might be asked a question on a cosine or sine or tan graph, so familiarise yourself with those graphs. That doesn't take too long to just look at the graphs if you're looking for an A star. Circular graphs maybe will come up, who knows. Design a data collection sheet, that was a real pain when that came up. All my students didn't know what a data collection sheet is because I always call them tally charts. But you know, if you ask for a data collection sheet, just remember it's a tally chart. And looking through this, conversion graphs could come up. Enlargements could be enlargement with a negative scale factor or a fraction are higher grade than the other transformations. So just remember that if it's a fraction, say if you enlarge the shape by a half, you go towards the centre of enlargement and you halve the distance between each of the points in the centre of enlargement. If it's negative, you go through the centre of enlargement and you get shape the other side. Product of primes, that's normally a non-calculated question, but just remember the little tree with the numbers coming out of it. I don't see an estimation, obviously won't come up. That would be a non-calculated topic. And highest common factor problem, lowest common multiple problem did come up before, but those are non-calculated normally. So there might be a few there that you might want to glance over, but these ones here are very, very low priority. The only one I think I can see is estimating from a histogram, which we've already talked about histograms before, but make sure you can draw histograms, but also make sure you can use histograms and you understand that the frequency on histogram is the area of each of the bars. I don't see any more. Maybe volume scale factor, knowing the fact that if you have a linear scale factor, if you know what the line's gone up by, you square it to get the area scale factor and you cube it to get the volume scale factor, but I'm pretty sure that won't come up. And I think that's it. So thank you very much for watching this video. As I said, if you haven't seen my predicted paper yet, then please click on the screen now to have a look at my predicted paper. Thank you.